So, the topic of discussion today is Webull's formula. Now, this is the first method that will be discussed in the series of risk analysis method. So, you can say this as first risk analysis method. So, generally, with the help of Webull's formula, we find the plotting position of an event with respect to the other events. Suppose you have been given 100 number of rainfall events, which are the peak rainfall of the last 100 years. Now, if you want to find the relationship between these events and its corresponding return periods, then you have to draw the Webull's plot. And from the Webull's plot, you can easily identify the relationship that exists between the magnitude of the events and its return period. Generally, log or semi-log paper is used to draw this type of plots, where in the y-axis we put the extreme events, the magnitude of extreme events. In the x-axis we put the return periods. But by applying Webull's formula, we find the probability of those events, and then we inverse the probability to find the return period of these events. The return period signifies the occurrence chance of this event for that number of years. That means if I say a storm has a return period of 100 years, it indicates that it is so rare that the chance of occurrence in the next 100 years is 1. So with this, return periods or the probability of events are used for risk analysis of different hydraulic structures, because with this we can estimate the frequency of extreme events that can take place in the location of interest. That means in the location where we are planning to build the hydraulic structure. So these methods and other related methods are implemented before the dam is installed or before a location is selected for the installation of the dam. So it is a part of pre-installation survey or project feasibility analysis. Okay, so Webull's formula is the most popular and also most basic and simple method for calculating the exceedance probability of certain number of events. Now, what happens in case of Webull's formula? You see, you will be given a set of extreme events, data of set of extreme events. In this example, I have selected the peak rainfall of last 5 years. Okay, peak rainfall of the last 5 years. Your first step will be to arrange these events in the descending order of magnitude and assign order or rank to each of the event, where the event with the maximum magnitude will be given the best rank, that is 1, and event with the least magnitude will be given the worst rank, that is the 5th rank, because here is the total number of events given to you. Total number of the events given to you is 5. And always remember, the worst rank will equal to the total number of data given to you. Now, here after doing these 2 steps, that means first arranging the events in descending order of magnitude and assigning order or rank to them, each of them, what we do is we apply this formula. This is the Weibull's plotting position formula. It is so what is that formula? M by n plus 1. Here M is the order or rank assigned to the event. In case of this event, 235 rainfall, peak rainfall of 2022, and this is the highest rainfall as per magnitude among all the 5 rainfalls given to you. So we have assigned the first rank to that event. So your aim will be 1. And divided by n plus 1. N is the total number of events given to you. Here, in this case, it is 5. So this will be ultimately 1 by 6. And the result is 0.1666. So as we round it up to 0.17. So this is your probability. To calculate the return period, you just inverse the probability. And when you inverse the probability, you have the return period. So in this way, you get a second highest storm. This is 150. So both peak rainfall of 2021 and 2019 are same, and both of them will get the second position as per magnitude if I arrange them in the descending order of magnitude. Now note that as there is a condition that total the worst rank will be equal to the total number of events available to you. So that is why you see, as these two is second, the fourth or the next highest event as per magnitude is assigned a rank of 4, because already 2 points, 2 events has taken the position 2. So that is why, to maintain that condition, we assign the next highest event a rank of 4. If there was 3 events that was in the same rank, then these should have been assigned the rank of 5. Okay, then suppose this is also 150. So this should become 2. So 2, 2, 2, 3 points is taken. So the next highest event will get the point 5. So in this way you have to adjust to maintain the condition that the worst rank will be equals to the total number of events available to you. So after getting the orders, then similarly as we have done for this event, we'll do the same for the other events also. So for the other events also, we do this 2 by 6, which would come around 0.32. This, the peak rainfall of 2020 has a rank of 5th position. So 5 by 6, m is 5, n plus 1 is 6, so 0.83. Then again, peak rainfall of 2019 is 2nd, so 0.33, and then ultimately 0.67. Now you see here I have not shown the arrangement as per the descending order of magnitude, but I have shown the order assigned to them. So this is the rank or order assigned to them. So after getting the probability, you inverse those probability and you will get the return period. For the highest event of the last 5 years, you see the return period is 5.88 years. Then the next highest events, that has a return period of 3.3 years, 3.03 years. Then the next one has a 1.49 year return period, and ultimately the worst rank holder, that is the least magnitude among the 5 data available, that has a return period of 1.20. Now you will draw a plot in a semi-log or log paper where y. So in the plot, this is the known as Weibull's plot. So in the y-axis, there will be the magnitude of the peak rainfall of the last 5 years. So you can say this as y is the peak rainfalls or the extreme events. And in the x-axis, you will have the return period. And we'll put down all this return period, like for example, the 1.2 year will get the first position in the x-axis, then you will go to 1.49 because they start from origin, then you will go to 3.3, then there will be 5.88. Similarly, in case of peak rainfall also, so the lowest one is 100, so there will be 100 and like this. So if you plot the position accordingly, so for this, the return period will be like this. So 2, so like a curve can be drawn something like this. Okay. So this will be a log paper or semi-log paper. We have to use a log or semi-log paper because this x-axis will be in a scale of 100 and 1000, as the magnitude of return period is very small compared to the magnitude of the peak rainfalls generally. So that is why this x-axis is in logarithmic base, and this is normal base. So this way you have calculated the exceedance probability with the help of Weibull's method. So generally what will happen is that you will be given suppose 10 to 20 number of events. The numerical problems, in case of numerical problems, you will be given total of 10 number of data. Suppose they will say that the peak rainfall data of the previous 10 years is as given below. Okay. The question would be, find the exceedance probability of those events with the help of Weibull's formula. Now, in case this is the problem given, then you will just follow the previous method. But if, as the second part of this problem, they say that find the exceedance probability of the events that they will not occur again. So if this is given also, find the exceedance probability of the events that they will not occur again, non-occurrence probability. Then don't panic, but the system is like that. First calculate the exceedance probability. Suppose this is P. And then just deduct the P from 1. So this will give you Q. This Q is actually the non-occurrence probability. Okay, so let us give you the 10 number of data. So the data is like this. So these are the X rainfall events of the last 10 years. Let it be the peak. Okay, this is would be the year. So this will be like this. So you see, this can be the year, this can be the, in 1 year, 12-month rainfall is given to you, and then they say what will be the excellence probability. Then also you can use Weibull's formula. The main funda is that you have to arrange all these events as per magnitude and in the descending order, and then assign order to them or rank to them, and then use the plotting position formula m by n plus 1 to calculate its excellence probability. So, and when you calculate the excellence probability, m by n plus 1, this gives you the excellence probability. And to find the return period, which is t, just inverse the probability. That is all you have to do. But in some problems, they will also ask about this one. Find the p of the events that they will not arrive. So in that case, just deduct the p from 1. We indicate the non-occurrence probability as q. So just deduct it. But although if you are given the non-occurrence probability, they will also give you the time period within which that storm will not occur. If no time period is given, then you have to just go for this 1 minus p. But if the time period is given and also the number of times, the frequency is also given for those events, then you have to do one thing. If only time period is given, then q will become 1 minus p to the power n. And if also the number of times, the frequency is also given, that this event will not occur for 2 times in the next 10 years, then you have to use this formula, 1 minus p to the power n minus r, where r is the number of times that event can occur and n is the number of successive years. That means the future years, of course, because all these things based on future. N number of successive years. What is the probability that this event will not occur for the next n number of successive years for r number of time? If this is the problem, then after detecting the p from 1, you have to power it up by n, this power, n minus r. And if this r is not given, then it will be assumed that r is 1. So n minus, then it is r is not there. Then you just power it up by the same thing, 1 minus p, power it up to the power n. Okay, so this is what you have to do, and let it be this problem. Let us return back to the problem. So you see, so there are 10 number of years, and now let me give you the magnitude of these years. Let this be 235. Let this be. These are all random events we have given. This is not the correct. 235, 150, 100, 150, then 120, then 100 again, then suppose 75, then for 120, 150, and then again 75. So you see, your first job will be to assign the rank as per the descending order of magnitude. So assign rank 235, as you can see, is the highest magnitude event. So highest magnitude event, so this one 235. So its rank or order will be best first. Then this one will be the second highest, same as this one. So second. So 2 gone, and there is another 150. So 3 points gone. So 1, 2, 3, 4. The next one will be the fifth. The next one will be in the fifth position. So fifth position storm, I think 120. So this one is 5. Another duplicate is there here. 5. Correct. So 2 position taken. 5, 6 is taken. Next one will be 7th. Let 100 be the 7th. Then again this one also has a duplicate 7, so 7, 8 is taken. Now this 75 is there, right? After 100 the next highest event is 75. So we have 7, 8 is taken, so this one will be 9 and this one will be 9. Okay, so these are the positions. Now let us use the formula P to calculate P. So similarly, m by n plus 1 you can do. One thing you can know, n is here 10, so this will be P will be equals to n is 1 divided by 10 plus 1, 11. So 1 by 11 will be the probability, and if you calculate the return period, then it just inverse, so 11 will be the return period. Correct? N is 1 for the best event, highest event, divided by total number of data points is 10 plus 1, 11. So 1 by 11 is the probability. Return period is inverse to the probability, so 11. Similarly, for the next is 2 by, what is that? The next will be second most event, second highest event, so 2 by 11. Correct. So 2 by 11, return period will be 11 by 2. So this will be around 5.5. And all the events that are the second position will have the return period as 5.5. Correct. So in this way you will take the fifth position now. So 5 by 11, 11 by 5. So the return period will be around so 11 by 5. So it will be around so divide 11 by 5 and it is coming right 2.2. So all the events which have the 7th position will have that return period 2.2. Okay. Sorry, all the events that have the position fifth position, that will have that. So in this way, now we'll get the event. The next highest event is has the 7th position. So 7 by 11 return period for return period, it will become 11 by 7. So the result is like this. A very so the result will be like 11 divided by 7, it is coming 1.57 return period. So all the events which have the 7th position will have the 1.57. Now take the event of 9. So probability 9 by 11, return period 11 by 9. So the return period will be 11 divided by 9 and it's 1.22. So in this way, you see, you have to calculate the return periods of all these events and then put it into the log or 7 log paper where y will have your magnitude of the events, x will have your return period. So, but it will, the x will be in the log axis and y will be normal. And accordingly, you will draw the curve, which will be like this, somewhat like this. So this will help in the risk analysis of your hydraulic structure. Okay, but this is all this approximation. This is not real. You are calculating the probability, not the exact time. Now, what I am saying is that if this part is also given, that find the probability of the events that they will not occur again, not occur, then you have to use the formula of Q is equal to 1 minus P. Now, take the first example. Here, the peak of the last 10 years, 235, the highest magnitude rainfall, which has a probability of 1 by 11, which have a probability of 1 by 11. That is, let me show one example, 1 by 11. That is a probability around 0.09. And the probability that they will not occur again, you can find it out by Q is equal to 1 minus 0.09. That means it is coming 0.909, so you can take it as 0.91. So there is a 91. If I multiply 100 with this value, then 91% probability is there that this event will not occur again. But this again term is a very vague term. So if there is no number is given that not occurring within how many number of units, then your job will be to just deduct the P from 1. But if the number of years is given that this will not occur again in the next 10 years, just 1 minus P to the power 10. Now, along with the time period, if the number of times or the frequency of the event is also given, then you have to deduct the frequency of the event from the number of years or the time period. So here let us calculate that. Find the P of the events that they will not occur again in the next 10 years for 2 times or 3 times. But here I will take for 2 times. That means we are trying to find the probability that this event will not occur for 2 times again in the next 10 years. So just deduct the number of times they can occur, that is 2, from the time period 10. 10 is the 10 years. So you have to power this 1 minus P to 8. So 1 minus P is 91. So you power this 91 to the power 8. That will give you the non-occurrence probability of the event. Correct? And another thing to notice, now let me see if I have to give, let me show that result. So if I power of 0.9, if I power this up, so if I power this up to 8, right? 10 minus 2 is 8. So if I power this up to suppose 8, then it is coming, you see, 0.43. If I power this term, 10 minus, 1 minus P to the power n minus r. Here P, we have already found out that P is around 0.09. So we deduct the P means the probability of that event, this event, 235. Then we deduct that 0.09 from 1 and we get 0.91. So if there is no n, no r, that means if the time period and number of times that storm will not occur is not given, then keep as it is, that is 91%. Result will then be 91%. But if the time period and also the number of times they will not occur again is given, that means n and r is given, then you have to power this equation 1 minus b to n minus r. Here n is dead, sorry, the time period minus number of times they will not occur, 2 times. So 10 minus 2 is 8. So this 0.91 to the power 8 is coming around 43, around 43 point 43.04%. So as it is 43.046, I can take it as 43.05%. Okay, so I hope you have understood the method, how we have to apply it, and how we have to calculate the exceedance probability, how we have to calculate the return period, how we have to draw the graph, and how you can also calculate the non-occurrence probability if time period and frequency is not given, and also if time period and frequency is given. So with this, I will conclude this presentation. Thank you.